January 1, Chapter 3, Learning Target 7, even though you've seen it on your weekly reviews a bunch of times. This is Miss Osier.
And Miss Lahar.
And here we go. Average rate of change, people.
Average rate of change.
You did this in algebra.
Yes, but you knew it then as the slope formula. Now look at this in function notation. So delta F, which just stands for the change in the output. So you take your difference of your y's over the difference of the x's. But that's what it looks like in function notation.
Right, so we're not doing slope of a line. We're doing the average rate of change, which you have seen before, over two functions. So they might not be lines, so you can't count the slope of a line.
Yes. All right, so number one, calculate the average rate of change for both the function and the following interval. Show your work carefully, yada, yada, yada.
Okay, so here, this is important. Negative 2 over 3, that's what you're substituting into the function in order to get your average rate of change.
Those are your x values.
Those are your
You
y
got to plug them in to get your y values.
Boom.
So if you do f of negative 2 and you put in f of 3, you get those following numbers, negative 3 and 22.
So now we have our y's and we have our x's. So we're going to do the slope formula with those y's and those x's. It's that easy.
You do it, you simplify, boom. Now, if you know it's a linear, you can just use the slope. But if you didn't know that, the average rate of change will still get you that.
Right.
So now we're doing it for g of x. We're plugging in negative 2 to be careful to put it in parentheses when you're squaring it, remember. And then we get 19 minus 9 over 3 plus 2. So you end up getting 10 over 5. Whoa, Miss Lahart.
That's okay, things happen.
3 plus 2 is 5.
10 over 5, which is 2.
Yep.
So all of this should say 2. Oopsies.
Heyo.
Moving on.
All right, so B. Most likely not in Algebra 2, they're going to ask you to compare the two average rate of change.
Yes.
So therefore, if the average rate of change of F and...
It's not going to change the answer, but this is 2. The answer's still going to be right, but this is 2.
Okay, the average rate of change of F was the same for both I and 2. What was the name for G? Why is that? Linear equations have constant... Oh, I forgot a different part, but whatever. Linear equations will always have a constant slope.
Okay, so usually... there was another one.
Yep, I forgot the other one.
Where you did f of x with 4 and 7, whatever. And you would also get 5. That's because this is a line. So no matter what, that slope will always be constant. What we anticipated this was going to say, but we forgot to change this here, was like which one's bigger, which one has the higher rate of change, something like that. So in this case, this would have the higher rate of change, the function f, because 5 is higher than 2.
Yep. Okay. All right, now out of a table. It's even easier. You don't have to think too much. You just got to know the difference between your x's and y's. So this is all about a person's pupil. As you age, it gets smaller. They want to know what the average rate of change is over the ages 30 to 70.
Yep. Now pay attention to your x's and y's. Usually time, so years, anything time-wise are your x's. So that's on the bottom. The output is the pupil diameter. Boop.
You plug in the values, you do the difference of the y's over the difference of the x's, and boom, there you go.
And then it says be sure to include units, so this would be 400 millimeters. Boom.
All right, now from a graph, again, also easy, you just got to go for your points. So in this one, they want you to find the average rate of change from 1900 to 2000. So I think I circle those two values. You look at your y's. And we kind of...
are estimating a little bit here.
Yes, 278, because that point is right above 275. So I said 278. As long as you're in the ballpark, you're going to do all right.
Now, we are going to have this exactly for you if you need it, because if we were assessing you on this, you would know 100% what the numbers are.
Right. So you do the difference otherwise, you get 3 over 100. And then they wanted to know if it was greater than the average rate of change from 2000 to 2010.
This should be 203, just saying.
No, it shouldn't.
278 minus
'cause
75?
1900, 75.
Oh, just kidding. But 278 minus 75 is not 3.
Oh, that value.
That should be 203 real quick.
Wow.
It's okay.
Miss Lahart is struggling.
It's okay. So this should say 2.03. And now we're going to do the same thing from 2010 to 2000, and we get 3.4. So luckily for us, this is still the higher one. So the average rate of change from 1900 to 2000 is less than the rate of change from 2000 to 2010, but this should say 2.03.
Yep.
It's okay.
Oh, look, there's that pop-up. All right, this is right from an Algebra 2 Regions exam. So they give you two different things. They give you an equation, and then they give you a function, and they want which one has the greater average rate of change over the interval, -2 to 4.
So we need to evaluate -2 and 4 for the function on the left.
Hopefully those numbers are right. I'm doubting my skills right now.
It's okay.
You can get that. I know. You can retake. Version B. Where's version B on video 1? And then we look at the table. We plug them in. Difference of the y's over the difference of the x's. Hoping that's, looks sort of right.
Looks good.
So then what would you say? G of X has a greater
G of
average
X.
rate of change over the
that
interval.
number is bigger.
Yes.
See that one? It's bigger than that one.
And that's the average rate of change.
Look at us go. All right. Well, we're going to make sure we're right in class. Have a wonderful day. We'll see you guys later.